Okay, welcome America, welcome India, and welcome Selena Gomez to the live studio recording of Pre-Calculus in Studio 202. Today we are going to do the basics. This is an introduction to trig identities. So what's going to happen with all these problems is you are going to have an identity which says that an expression equals another expression. And you have to prove it. The phone should be away. This is new information. Totally new. These have to be done a very specific way. You have to work on one side of the equation and show that that side equals the other side. It doesn't matter which side you start on. Usually I like to start on the one that's the most difficult and work towards the one that's less complicated, that's more like one. But a lot of times you have choices, and a lot of times you try something, it doesn't work, and you try something else as the problems get more difficult. The problems today are pretty basic just because we're learning the process. So for problem number 3, and you can use any of the properties that you've learned up until now. So you might do the problem a little differently than I do, or your neighbor, and if we end up with the same thing, then it's fine. And a lot of times you'll have 2 mistakes that cancel each other out, and you'll think it's right, but you make 2 mistakes. So I'm going to start this one on the left just because I can write tangent and cosecant as reciprocals and just see what happens. So that means I'm not doing anything with the right side. But to show everybody I'm working on the left side, I need to put an equal sign on the right. So I'm going to rewrite tangent, as sine of x over cosine of x. And then I'm going to write cosecant as 1 over sine of x. And I'll put an equal sign here to tell everyone I'm working on the left side. And I'm definitely going to run out of room. That's okay. Now, I've got a fraction over another fraction. So I'm going to do keep, change, flip. Does this sound familiar? Keep, change, flip. Keep the sine over cosine. Change the division to multiplication and flip the denominator. And now I have basically the same thing that's on the right side. But I have to rewrite it. So I wish I had a whiteout. Scratch all that. I'll just keep going down here and we'll erase it and do it again. This is sine squared of x over cosine of x. Now my left side is equivalent to my right side. So I'm done, but the way I show I'm done, and I forgot my equal sign here. Equals, equals. Now I can write the other side because they're the same. And I have just verified that identity. And I did that problem when I did these problems the first time. I did it a different way, and I got the same answer. So there, it doesn't really matter. Questions? The problems are going to get, after today, like the next lesson, they're going to get more difficult. Okay. So I'm going to erase this, and now we're going to go to number 5. Now, number 5, and again, you've got choices, okay? But I thought, I'm gonna go ahead and start this one and show you how to work on the right side if I choose to do that. So I see I've got secant and tangent. I'm adding them. So I'm gonna write those as reciprocals first, okay? This is 1 over cosine plus this is sine of x over cosine of x. Now I have, and I'll put equals on this side to show everybody I'm working on the right. Now I have 2 fractions that have the same denominator. And back from algebra 1, when we had 2 fractions that had the same denominator, we can now add them. So this is equal to 1 plus the sine of x over the cosine of x. Is everybody okay with why I'm just writing cosine of x and not 2 cosine of x or cosine squared? It's because we're adding those two fractions. I mean, if that was 1/2 plus 3/2, we would say it's 1 plus 3. It's 4/2, right? The 2 stays in the denominator. That's what we're doing here. Are we good with that? Now my right side looks just like my left side, so I can put this in. And it's verified. How are we doing? Some of you guys that took Algebra 2 Trig have seen this before. If you took regular Algebra 2, you have not. This is totally new, and that's perfectly fine. Anytime something is totally new, it's tough. So some people in this class might be like, oh yeah, that's easy, and other people are gonna be like, what the what? And that's okay. All right, we are gonna go to problem number 8 in the next video.